The topic is eigenvalues and eigenvectors. The eigenvalues and eigenvectors can be found out for the square matrices only. The square matrices means that is either 2 by 3, 4 by 4, whatever it may be. But here, in general, we are taking almost 3 by 3 and 4 by 4 matrix. Here, suppose A be the square matrix. With order n. With order n. Suppose I am taking, for example, either 2 or 3. Okay. Here, how to find out the eigenvalues means the eigenvalues can be finding by using of the characteristic equation. The characteristic equation is determinant of A minus lambda I is equal to 0. From this, taking the determinant, if we are taking 2 by 2 matrix, then the lambda is in square. If we can take 3 by 3 matrix, then the lambda value is in cube. For example, I am taking A is equal to 1, 2, 3, 4. This is the 2 by 2 matrix. Now we know that identity matrix I2 is, that is nothing but second order, 1, 0, 0, 1. The characteristic equation is determinant of A minus lambda I is equal to 0 means only the diagonal elements are from that lambda is subtract. That is 1 minus lambda, 2, 3, 4 minus lambda. Why? Because identity elements in that only the diagonal elements are unit elements, the remaining all are 0. So, if we can subtract the lambda I from A, only the diagonal elements can change. Now we can take the determinant. Determinant means AB minus BC. That is 1 minus lambda into 4 minus lambda minus 3 to the 6 equal to 0. From this, we can write 4 minus lambda minus 4 lambda minus into minus plus lambda squared minus 6 equal to 0. Here it is lambda squared minus 4 lambda, it is minus 5 lambda. 4 minus 6 is minus 2 equal to 0. Now we are getting the lambda values. Lambda equal to minus b plus or minus under root of b square minus 4ac. 4 to the 8 by 2a. It is equal to 5 plus or minus under root of 25 minus 8 by 2. Then lambda equal to 5 plus or minus root 17 by 2. Here the lambda values are lambda equal to 5 plus root 17 by 2 and 5 minus root 17 by 2. These are the eigenvalues. If I am taking any example of 2 by 2 matrix, just so you can observe here 2 by 2 matrix means we are getting the lambda quadratic equation. If we can select 3 by 3 matrix, then the lambda power is in 3. Okay. From that, after solving out that cubic equation, we are getting lambda values are 3. One is A1, A, B, C, or the lambda values. These lambda values are called as the eigenvalues. In this, the eigenvalues are calculated from the characteristic equation determinant of A minus lambda I equal to 0. That is the condition. Next, how to find out the eigenvectors? Eigenvectors means in that we can take the characteristic vector equation. The characteristic vector equation is A minus lambda I into capital X equal to 0. where X is the, if we can take 2 by 2 matrix, then X1, X2 are the two variables. This is a column matrix. If A is the 3 by 3 matrix, in that X is the, X has three variables, X1, X2, X. Okay, this is the 3 by 1 column matrix. By using of characteristic vector equation, then we get the vectors. If we can substitute lambda equal to A, then we are getting the X1 is the corresponding characteristic vector. In this X1, we can take X1, X2, X3 if it is in 3 by 3 matrix. If A is in 3 by 3 matrix. If lambda is equal to B, then we can substitute in above matrix. In that, the corresponding vector equation is X2 is Y1, Y2, Y. Then after simplify and cross multiply by taking the multiplication of X and A, solving of that, we are getting the variable values. If lambda equal to C, then we can take the vector is the third vector Z1, Z2, Z. If this is the procedure how to find out the eigenvector. Suppose I am taking 3 by 3 matrix and how to solve the, how to find out the eigenvalues and the eigenvectors. Find the eigenvalues and corresponding eigenvectors of A equal to 3, 2, 2, 1, 2, 2, minus 1, minus 1, 0. In this, first we can take A matrix and take the characteristic equation is determinant of A minus lambda I is equal to 0. Determine only the diagonal elements in that lambda is subtract. 3 minus lambda, 2, 2, 1, 2 minus lambda, 2, minus 1, minus 1. 0 minus lambda is minus lambda equal to 0. Most of the students here, 0 is there, then here also taking 0, then you get the wrong answer. So we have to remember the diagonal elements, from that lambda is subtracted. From this, we can take 3 minus lambda into elimination of corresponding row and column. Then minus lambda into 2 minus lambda, minus into minus plus 2, minus 2 into 1 minus 1 into minus lambda, minus into minus plus 2, 1s are 2, plus 2 into 1 into minus 1, minus into minus plus 2 minus lambda equal to 0. From this, 3 minus lambda into minus 2 lambda plus lambda square plus 2 minus 2 into multiply with minus 2 minus into minus plus 2 lambda minus 2 to the 4 minus 2 1 the 2 plus into minus minus, and here taking simplification plus 1 minus lambda, then it is 2 1 the 2 minus 2 lambda equal to 0. Minus 2 lambda plus 2 lambda get cancelled. Here multiply with 3 minus lambda minus 6 lambda plus 3 lambda square plus 3 to the 6 minus into minus plus 2 lambda minus lambda cube minus 2 lambda minus 4 plus 2 minus 2 equal to 0. Here simplify minus lambda cube. Here plus 3 lambda square plus 2 lambda minus 2 lambda get cancelled. It is minus 6 lambda plus 4 equal to 0. From this, we are getting, taking sub minus common, lambda cube minus 3 lambda square plus 6 lambda minus 4 equal to 0. Here, small correction. 3 twos are minus 6 lambda plus 3 lambda square plus 6 minus into minus plus 2 lambda square. Two lambda square minus lambda cube minus into minus into plus minus 2 lambda. So it is all get cancelled. Minus 2 lambda. Now here, this is listed. Minus lambda cube 3 plus 2 plus 5 lambda square minus 6 lambda minus 2 lambda, that is minus 8 lambda plus 4 plus 6 minus 2 plus 4 equal to 0. Taking minus common, lambda cube minus 5 lambda square plus 8 lambda minus 4 equal to 0. By the synthetic division, 1 minus 5, 8 minus 4, 1, 0, 1, 1 minus 4, minus 4, 4, 4 ones are 4, it's 0. So lambda equal to 1 is the one root, and this is in the quadratic form, lambda square minus 4 lambda plus 4 equal to 0. It is in the form of lambda minus 2 whole square equal to 0. Therefore, the eigenvalues are 1, 2, 2 or eigenvalues. These are eigenvalues. Next, we can find out the eigenvectors. For case 1, take lambda equal to 1, substitute in a minus lambda I, that is equal to a minus I. Here a minus I is equal to 3 minus 1. 3 minus 1, 2, 2, 1, 2 minus 1, 2, minus 1, minus 1, minus 1, 0 minus 1. It is equal to 2, 2, 2, 1, 1, 2, minus 1, minus 1, minus 1. It is a minus lambda. Let x equal to x1, x2, x3 be a characteristic vector. Then the characteristic vector equation is a minus I into x equal to 0. Here 2, 2, 2, 1, 1, 2, minus 1, minus 1, minus 1 into x1, x2, x3 equal to 0, 0, 0. Here R3 to R3 plus 2R3 plus R1. R2 is 2R2 minus R1 by taking the elementary operations. Then we are getting the R1 is divides with 2. 1, 1, 1, 2 R2 minus R1, 2 minus 2 is 0, 2 minus 2 is 0, 2 to the 4 minus 2 is 2. It is multiplied with 2 and adding minus 2 plus 2 0, minus 2 plus 2 0, minus 2 plus 2 0 is x1, x2, x3 equal to 0, 0, 0. Next, expressing into equations x1 plus x2 plus x3 equal to 0, 2x3 equal to 0. From this, x3 is equal to 0. Substitute in above equation, then x1 plus x2 equal to 0. Here, let or take x2 is equal to k parameter, then x1 equal to minus x2 equal to minus k. Therefore, x equal to x1 is minus k, x2 is k, x3 is 0 equal to k is taking common minus 1, 1, 0 be the characteristic vector corresponding to lambda equal to 1, or it is the characteristic vector for lambda equal to 1. This is the way. In the same way, you can take another vector x equal to y1, y2, y3 be the characteristic vector. Then the characteristic equation, you can take the case 2. That is the case 2 is take lambda is equal to 2. Then the characteristic vector equation is a minus 2i into x equal to 0, where x equal to taking another variable y1, y2, y3. The same procedure you can apply in that you are getting the another vector equation. Why? Because here 2 is the repeater, then you are getting the only single. Again, I am solving that one. That is just I am directly write the values. 3 minus 2 is 1, 2, 2. 1, 2 minus 2 is 0, 2, minus 1, minus 1. 0 minus 2 is minus 2, 2. Y1, Y2, Y3 is equal to 0, 0, 0. Here, R1 into R1 minus R1 only, R2 into R2 minus R1, R3 into R3 plus R1. From this, after the simplification, first row is as it is. 1 minus 1 is 0, 0 minus 2, 2 minus 2 is 0. 1 minus 1 plus 1 is 0, minus 1 plus 2 is 1, minus 2 plus 2 is 0. 2, y1, y2, y3 is equal to 0, 0, 0. Next here, this is reduced to 0, R3 into 2, R3 plus R2. Then it becomes 1, 2, 2, 0 minus 2, 0. And here R2 is divides with R2 by minus 2. It becomes plus 1, 0, 2 into 1. 2 minus 2, it's 0, it's 0 into y1, y2, y3 equal to 0, 0, 0. Again expressed into equations y1 plus 2, y2 plus 2, y3 equal to 0, y2 equal to 0. y2 substitute in the above equation, y1 plus 2, y3 equal to 0. Take y3 equal to k1 is a parameter. Then y1 equal to minus 2 y3, it is equal to minus 2 k1. Therefore, capital X equal to y1, y2, y3 is equal to y1 is minus 2 k1, y2 is 0, y3 is k1. Taking K1 is common, minus 2, 0, 1 be the corresponding vector to lambda equal to 2. This is the characteristic vector corresponding to lambda equal to 2. This is the procedure how we can find out the eigenvalues and eigenvectors.